Next presentation with Juliette Becquet and Santos. Juliette did a PhD in the INRAE lab in Riverde, and Dos Santos, who runs the TEREO engineering office, and it's a joint project within the framework of a CIFRE PhD. Well, the PhD student is actually employed by the company or the local authority, by way of example. So you have the floor. Let me explain to you the origin of the project of this CIFRE PhD. TEREO is an ecological engineering office based in Saint-Thérèse-du-Lac in Savoie. Was created in '95, and they specialized in the aquatic and land ecosystem. 80 employees, most of them work in the head office. There is one agency in the Hautes-Alpes department, and the brand new branch in Brittany. Field of action where we help project holders at every level, from the design, of course, all the administrative authorizations, and in post work in follow-up and management, long-term management plans. Our commitment is to provide an ecological response which is suited, adapted, and based on the competence, scientific competence and knowledge of our employees. For several years now, we do work on the creation of micro power plants or samplings in catchment basins, heads of catchment basins of the torrential rivers. With all those projects started with the Environment Commission, which promoted the renewal of the renewable hydroelectrical power plant. Well, we have an impact assessment, and there is also the notion of minimum biological flow rate. We use microhabitat models developed quite a while ago, based purely on biological cycles of fish species, and which we also expanded that to macroinvertebrate and also in plain rivers. We ended up having mountain rivers, which sometimes used for fish farming, so we can't use the fish model, with somewhat sometimes surrealistic requirements from the administration, because we had to give minimum biological flow rate, whereas there were fish farms along the riverbed. So in order to be able to provide the answers, we ask ourselves several questions in-house first. So what was the most relevant biological group to define this biological flow rate, minimum biological flow rate? What were the effects of the modification of thermal or hydrological regimes associated with the stabilization of flow rates over several months during the year, and the various stages of the biological cycles? All the questions, you ask yourself when you want to modify or assess a biological flow rate. For 2 or 3 years, we thought about our needs, and all the questions that were still there, and we wanted certainly to find suitable responses or answers to these catchment basins of alpine rivers or mountain rivers. So we got via our network and people we worked with at the OFP, we got in touch with a INRAE laboratory to define and translate our needs, operational needs, and turn that into scientific equations. So the CIFRE PhD project was born then, and following the discussions, we agreed upon a project with scientific and operational objectives, and we initiated this PhD in 2019. We organized that with Juliette, who's brilliantly actually successfully got a PhD after 3 years of work. So she will now describe the scientific part of the project. Good morning. Juliette is my name. First, let me define the context. What is a mountain catchment basin? Well, in the rivers, usually originate from various locations, from glaciers, snow, rain, or underground water tables, and this will cause different hydrological regimes. In the glacier river, there will be high flow in summer, whereas in the other rivers, there will be two peaks in spring and fall. They will cause different physical-chemical conditions. Status rivers from glaciers are colder and more with higher turbidity, and it will also change the hydraulic characteristics of the river sections, like a flow rate, depth, and the force of the water on the riverbed. All those features, environmental features, will create a very specific, will lead to a very specific aquatic fauna. And I paid more attention to macroinvertebrate. Why? Because they are present in all rivers, almost. They are an integral part of the food chain, and they are also used routinely by design offices or engineering offices to assess water quality as they integrate environmental disturbances in the rivers or perturbations. So today, several studies have paid attention to the link between the various environmental characteristics in a mountain river and the populations of invertebrates who are there. But what was missing there was no study had simultaneously quantified the hydrology, the physical chemistry and hydraulics on the populations or the communities in several catchment basins with variable glacier influences and in several types of rivers. This is for the fundamental part. And as Anne just said early on, in addition, what we see is strong development of small hydropower stations in the Alps. There are about 300 of them as projects are already built, just in Haute-Savoie, Hautes-Alpes, and Alpes-Maritimes. And when it comes to for each works, we have to define, the minimum biological flow rate, which guarantees the circulation, reproduction of species who are in the waters when the works is being erected. To calculate this minimum biological flow rate, the design office use the hydraulic habitat model, which couples a biological model with a hydrological model. The biological component will make it possible to predict the abundance of organisms according to the hydraulics variable, whereas the hydraulic model will tell us how the hydraulic variable will evolve according to the flow rate. By coupling both, we get this type of charts, surface potentiality, useful potential surface, or species, like fish in this case, according to the flow rate. But the problem is that until now, such models have been developed for fish and for macroinvertebrates in low altitude. So we had models up to 800 meters, and they were never adapted to alpine or mountain rivers, and this was a problem, as we said early on, to assess the minimum reserved flow rates in rivers without fish. So to overcome such lacks or missing elements, so my thesis comprised several parts. First, at the scale of the catchment basin, we will try to characterize the links between the environmental conditions and the macroinvertebrate communities in the alpine rivers. So there's these three catchment basins. 66 sites. At the macrohabitat then, second scale, was to develop hydraulic preference model, that is the biological reference of the model for some taxons that are present in high quantity in alpine rivers. Third part of my thesis was to do the implementation of the new alpine models using a case study of a small hydroelectrical power plant in an altitude river in Savoie. Now, let me now give you very simplified presentation of the method and the main results for each part. Part 1, 3 catchment basin with different glacier influence. The Arvan, Vanoise and Arve close to Chamonix in Savoie. And we studied 66 sites where we sampled 5 suburbs, that is, samplings with nets of macroinvertebrates. And we had 330 samplings of macroinvertebrates. For each site, we measured the physicochemistry and hydraulic variables, which are described in the introduction. And we also assessed the hydrological variable from hydrological model called J2000, and we analyze this using a multivariate and mixed model systems. Main results of the first part, we identified 45,742 individuals which have been sorted and identified from 187 taxons, and we did models on 23 taxons. The main results, one of the main results of the study was that 93% of taxons modelized were actually negatively impacted by high turbidity. We also obtained 43% of taxons who were impacted by high flow rate, summer flow rates, and 43% of taxons were impacted by the velocity. And this has a role of the physical chemistry and hydraulics. And this will confirmed by the second study. We zoomed at the microhabitat scale. This time we went on 5 sites only with variable environmental conditions. We sampled 30 suburbs, and we had 150 samplings of invertebrates. And at each microhabitat, each samplings, we measured the hydraulic variables, velocity, height, and riverbed stresses, and also the hemispheres, which have been calibrated, and various densities make it possible to do a direct assessment of the sea riverbed constraints, and we did mixed models from this data. Out of the 140 taxons identified, we were able to do hydraulic preference model on 41 taxons. 17 had the significant response to the seabed constraints. It is significant, but it is also coherent between sites. So, and among the 17 taxons, 11 had a rheophile response. They wanted high constraints at the sea river. And 6 had limnophile response for lower, that is low riverbed constraints values. And out of the 17 taxons with significant response, we found 8 which were common with another study done in Plain River at a lower altitude. And it's interesting to see that with the same taxons, we do have a high degree of transferability, but of hydraulic response to alpine rivers or mountain rivers and plain rivers. Third part of my thesis, we implemented the new alpine models thanks to the monitoring of the microcentral hydro power plant of Saint-Jean d'Arc. You see on the right-hand side, a high-bird view. You see the flow rate top from bottom with the dam or the water sampling catchment. Sorry, we characterize the hydrology of the river based on the J2000 hydrological model and the specifications of the power plant, and we were able to assess a natural flow rate and an influence flow rate. And then by applying the hydraulic habitat model based on this section with a biological model and hydraulic model coupled, we were able to assess in this small power plant what percentage of habitat is lost for the dadaism. We did it on several species, so we can assess the number of habitat lost between natural flow rates and the flow rate which is influenced by the hydropower plant. And I will now give the floor to Anne for the conclusions and collaborative work. Now, by way of conclusion, this was made it possible to enter the world of research because we are more actually applied science. So It was a lovely human and scientific adventure. The results of Juliette's work will make it possible to complete the various tools we have to assess the impacts and what was missing. And work remains to be done, especially, for example, she wasn't able to confirm all the results. And we wanted the Juliette's works to be free, to open to the scientific committee. She did a presentation in front of an international jury, and therefore we were able to initiate a R&D approach in our office with our employees, and we'll continue with the Juliette's work with the INRAE lab to really get to the end of this research project and development of the tools. Thank you very much for your attention. Thank you, Juliette. And do we have questions, comments on this project? Good morning. Hello. Brilliant. Most interesting. Congratulations for this work. Now, my question, rivers you worked on, I mean, are they all like the one we see now on this photo, or are there different typologies? And so you talked about 30 surveys in 5 rivers. Now, did you have a special strategy to define the sampling sites in the rivers? Could you tell us more about that? Yes, sorry. Yeah, sorry, we had to be brief, so I didn't detail all the methods. Concerning your first question, well, this river was not used in my thesis. Sorry, in my PhD, so we had a couple looking like that, but not that much. We had different characteristics. We had flat rivers with strong glacier influence. Here, for example, in Saffron Valley, with but we also had ice-sloped torrential rivers with narrower. So we had a broad range of mountain rivers out of the 66 sites. When it comes to the samplings, transfer samplings in the 5 sets to develop the hydraulic habitat models, we had stratified systems. That is, since we wanted to develop our model between the highest and lowest hydraulic stresses or constraints, we looked for microhabitats where flow rate was 0, and also others where they were at the highest. So it is simplified sampling. Hello, thank you. I'd like to know if the warming up of mountain river water is already observed, and does it have an impact on the population? Yes, clearly there is a warming up of the mountain river waters, and in the Alpine rivers in all over Europe, actually. Yes, indeed, the rivers are getting warmer. So maybe, globally it gets warmer, yes, and it probably has a strong influence on the communities. And even if I didn't show it here, temperature, in my first study, we evidenced the role of turbidity, flow rate, and mean summer flow rate, and what comes after that is temperature, which clearly defines the behavior of communities. It probably has an impact. And what we do and observe is that the species which were usually found in lower altitude are now colonizing rivers high in the upstream. Thank you for this presentation. Was there an effect of the stability of the substrate in your study? Did you look at that? Well, stability of substrate. This is taken into account with the with the measurement of the constraints at the riverbed, but in several studies they would measure the Reynolds number or all the stresses or constraints that we did not take into account because we had to make choices in what we were going to measure. I want to say that it is taken into account indirectly, both by the measure of the constraints on the riverbed and the turbidity measurement as well, because in some rivers where the substrate was highly mobile in the catchment basin, there was a higher turbidity. The Arvan rivers, for in Savoie, we had high turbidity values, although there was not that much glacier influence, but we did not measure that precisely, so I cannot give you a precise answer either.
Were there differences in impacts on different taxa? In other words, were there groups of taxa that you could see had different responses in different regions? Do you understand?
I'm not sure.
Were there groups of, you had 130 taxa, were there different responses for different types of macroinvertebrates?
Do you mean if we observed some differences of some guild of responses?
Yes.
This would be the objectives, to have some kind of guides, to facilitate the readings or the interpretation of results. For the time being, what we've done are posteriori guilds. Well, we said, taxa which are, I'm talking about the third part of my PhD, the implementation. All taxa which will be most impacted, we class them in aminophil rheophile plus, then rheophile, and then hymnophile. But we could well imagine to have something wider with more species included, and then we could possibly quantify the impact on. It could, if it is associated with a hydraulic response, but it will be associated with other functional aspects, such as those who are more cryophiles or would have colder, who favor colder temperatures, it would be a great thing to do actually in the rest of my work. Absolutely. Thank you.